We've been drawing a bunch of Lewis structures, but they've all been fairly simple. And I think you can see that if we continue to try to draw Lewis structures in that simple fashion with more complicated molecules, it could get very complicated very quickly. Trying to draw the dots around the symbols and pushing them together and see who's sharing with whom and whether or not you need a double or a triple bond, it can get very complicated very quickly. So what we want to focus in on this video is a systematic way of drawing Lewis structures. All textbooks will go through this list for you. I've got my own list for you, but all of them start with number 1, draw the skeleton. I have a handout. If you're in my class, you'll be getting this handout. And basically step number 1, draw the skeleton. Usually the central atom in a molecule is listed first in the formula and all the atoms are attached to it. There are some exceptions. If hydrogen is listed first, then the second atom is the center. When drawing the atoms attached to the center, use a single line, which indicates a single bond made up of 2 electrons. If you draw the attached atoms in the up, down, left, and right directions, this makes it easier to count to 8 for an octet. So let's put that into practice with our first example, and let's do a fairly simple example. Let's do an NH4+. Now notice that this is an ion. This is one of our polyatomic ions. This is the ammonium ion. It is made up of nitrogen and hydrogen, which are nonmetals. So the nitrogen and hydrogens in this polyatomic ion are covalently bonded. Even though once they are covalently bonded, they go participate in an ionic bond with some other anion, they themselves are covalently bonded, so we can draw their Lewis structure. So step number 1 was to draw the skeleton. So let's stick our nitrogen in the center. Most of the time, the first atom listed is the center and everybody else is attached. So I have my 4 hydrogens attached to my nitrogen. I am sticking to the up, down, left, right position so that I can count to 8 more easily. And then one thing is when you're drawing a Lewis structure of an ion, and it's only an ion if you see the ionic charge written, it is customary to put that Lewis structure in brackets and indicate the charge on the ion in the upper right hand corner. This is just notation. So all I've done so far is I have drawn the skeleton for NH4+ by putting the nitrogen in the center, the 4 hydrogens around it, and then I've added the brackets and the plus charge because this is a polyatomic ion. Step number 2. Step number 2 is to count up the valence electrons. You will tabulate the total number of valence electrons in all the atoms that make up the molecule. Eventually these electrons will be shown in the Lewis structure. So come back to my nitrogen and hydrogen. Nitrogen is in group 5A, so he has 5 valence electrons. Hydrogen comes in with 1, but notice there are 4 of them, and this makes 9 electrons. The thing you have to watch for is if you have an ionic charge, because it's a polyatomic ion, you also have to account for that charge. I would be finished if this were neutral, but I'd also be scratching my head because this is an odd number of electrons. And in this course, we will stick to even numbers of electrons so that all of our electrons in our Lewis structures, once we're building the molecules, will have an even number so that all of our electrons are in pairs. Since this is a polyatomic ion, it has a positive charge. That means that as a group, it is missing 1 electron. Remember that a positive charge means it's missing electrons, a negative charge means it has extra electrons. Now it turns out that for the polyatomic ions, the missing electrons or extra electrons are in the valence shell. These are the ones that participate in bonding. So it is missing 1 electron, so I would subtract 1 electron from the valence electrons and say I have a total of 8. Now, don't worry about trying to figure out, well, is it the nitrogen that's missing it or the hydrogen that's missing it? It doesn't matter. As a group, there is 1 electron missing. So there will be 8 electrons that I will use to finish my Lewis structure. So step 2, count your valence electrons. Remember that if you have a polyatomic ion, you must account for the charge on the ion. We're ready for step 3. Step 3 is to add the remaining electrons. Remember that you've already added some of the valence electrons when you drew the skeleton, when you made the single bonds. So determine how many electrons still need to be added and then add them in such a way that every atom has 8. This is the octet rule. You will always add the electrons in pairs. Remember that there are some exceptions to the octet rule, like hydrogen. You're going to add them, and this is very important, you're going to add them in lone pairs around the outside atoms first, and then you'll work your way toward the central atom. You are not to make any double or triple bonds at this point. And so if we come back to our structure, we have 8 total electrons that we're going to add. We look at our structure and we see, let me count with purple, that we have already added 2, 4, 6, 8 in our Lewis structure, and so we have already added all 8 of those electrons. Let me take those away so that you can see it. We are finished with our Lewis structure because we have added all 8 electrons by simply building the skeleton, and sometimes it does work out that easy. So far we've used the first 3 steps. We've satisfied everybody's octet. We used all of our electrons, so this is the Lewis structure for NH4+. Let's do another one. Alright, let's do the molecule HCN. This is called hydrogen cyanide. It contains 3 nonmetals, hydrogen, carbon, and nitrogen. If you dissolve it in water, it acts like an acid, but as a molecule, it is a covalent compound. Therefore, we can draw a Lewis structure showing the sharing of electrons. Step number 1, draw the skeleton. Just to remind you, usually the central atom in the molecule is listed first, and the others are attached to it. There are some exceptions, and here we have an exception. Hydrogen, if it is listed first, is not the center. Hydrogen will never be the center because hydrogen can only ever have 2 electrons. Remember, it's an exception to the octet. Hydrogen will always be an outside atom, so we'll go to carbon for our center, and we will draw the hydrogen and the nitrogen attached to the carbon. I'm going to draw them off to the side. You could draw them up and down. You could draw one up and off to the side. That part doesn't matter for the Lewis structure. Even though it's called a Lewis structure, it's really not showing a structure, and so it doesn't really matter how you attach them. A Lewis structure is simply showing all of the electrons that are participating in the bonding and how they're participating. It does not give a 3-dimensional representation of what the molecule looks like. We'll get to that in a later video. So there is my skeleton. Step number 2, count my valence electrons, tabulate the total number of electrons that this structure should have. So I'll come down here. Hydrogen comes in with 1 electron, carbon comes in with 4, nitrogen comes in with 5. So there will be 10 electrons when I am finished with this structure. Now notice we haven't put 10 in yet, so we do have to look carefully at the next rule. Step number 3. Add the remaining electrons. We've already added some. Determine how many still need to be added, and then add them in such a way that everybody has 8 for the octet rule, unless it's an exception. You will always add them in pairs. Add them in lone pairs around the outside atoms first, and then work your way toward the central atom. Do not make any double or triple bonds at this point. So here we go. I have 10 electrons that I'm going to be adding in total. I've already added 2, 4, so I will start with the outside atoms and add them in lone pairs. Now I'm not going to start on the hydrogen. Hydrogen is finished once he has 2, so I don't add any more electrons to hydrogen. The other outside atom is nitrogen, so I'll start adding my lone pairs to nitrogen. So let me count again because I get confused easily. 2, 4, 6, 8, 10. I just added my remaining electrons to the outside atoms, or atom in this case, because I didn't add any to hydrogen, until I ran out. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 electrons are what are shown in this structure. Let me go back to Rule 3. If you satisfy all the octets at this point, you are finished with the Lewis structure. Stop. Take a look at our Lewis structure. We have not satisfied all the octets. We still have to satisfy carbon's octet. Nitrogen is happy as he can be, 2, 4, 6, 8, but carbon is not. If you have run out of electrons before every atom has an octet, then you're going to proceed to what I'm calling step 4. There's also a line if you have extra electrons, but that's not the scenario we're in. We've run out of electrons before carbon has an octet. And so now we're going to go to step 4. And step 4 is if and only if you run out of electrons before all atoms have an octet, then you're going to try double bonds and triple bonds to satisfy the octet. Very clearly, if you added the electrons as indicated up in step 3, it will be the central atom that does not have an octet yet. So you're going to take a lone pair of electrons from an outside atom and move the pair into a bond with the central atom shared, making a double bond. If the structure can be satisfied with double bonds, you may need more than one double bond, then stop. If you are finished with, or you are finished with the structure if the octets are satisfied with double bonds. But if double bonds aren't enough to make octets for all atoms, go to triple bonds. And again, take lone pairs of electrons from an outside atom and move it into a bond between the outside atom and the central atom. And so essentially this is this in action. We're going to take a pair of electrons from an outside atom and move it into a bond. So pencils, when you draw Lewis structures, pencils are good because you do a lot of erasing. And so we'll move that pair of electrons. So now we have a double bond between the carbons and the nitrogen. Notice that nitrogen still has 2, 4, 6, 8. He still has his octet. Carbon has 2, 4, 6. He doesn't have an octet yet. I can't make him happy with just a double bond, so I'm going to take another pair and move them into a bond and make a triple bond. I left one of the lone pairs on nitrogen. I didn't need to use it. Nitrogen has 2, 4, 6, 8. Carbon now has 2, 4, 6, 8. Hydrogen only has 2, but that's all he wants. That makes him happy. And I end up with a triple bond between the carbon and the nitrogen. So this is the Lewis structure for HCN.